Okay, let's talk about the derivation of the Nernst equation. Okay, the Nernst equation is used to determine the E cell value, so the voltage potential of a cell when the reaction proceeds at non-standard conditions. Okay, so remember, standard conditions are 1 molar solutions, 1 atmosphere of pressure for gases, and 298.15 Kelvin for temperature. And so the Nernst equation is derived from the previous chapter when we looked at Gibbs free energy. Delta G equals delta G standard conditions value plus RT ln of Q. From our current chapter, we have Gibbs free energy is equal to negative NFE of cell. Remember where N is moles of electrons involved, F is Faraday's constant. So if we substitute in the negative NFE cell into the previous equation, we get what you see. Now let's divide each side by negative NF, the product negative NF. That leads us to E cell equals E cell standard values minus RT over NF ln of Q. We can go ahead and substitute in our standards values for RT and F. Simplify it. Okay, and we get E cell value at non-standard conditions is equal to the standard cell potential, okay, minus 0.0592 volts divided by N, remember where N is moles of electrons involved, times the log of Q. Okay, remember Q is a reaction quotient similar to K value, an equilibrium constant, except with reaction quotients we're not at equilibrium, and so we look at it as a Q rather than a K. Our E standard cell value is still found from the reference tables in your textbook, where the standard value of the cathode minus the standard value of the anode. Okay, and then that can be substituted in. Now, some interesting things relating Q. When Q is equal to 1, then your non-standard cell and your standard cell have the same value of volts. When Q is equal to K, so Q is equal to the equilibrium constant, then the E cell value is 0 volts. Okay, 0 volts. We would consider it like a dead battery. Okay, and then when Q is greater than 1, so then your E cell non-standard value is going to be less than your standard cell value. So those concentration changes, those changes to the situation are reducing the cell potential, lowering it. You're going to get fewer volts. But when Q is less than 1, your E cell value, that's non-standard conditions, will be greater than your standard cell potential. So you're going to have a higher voltage.